Hello everyone, I'm Amos and today I will be talking about VineSense, which is a sensor network for vignette monitoring developed by an Italian company n9633359. So what is VineSense? Basically, it's a wireless sensor network for on-field agricultural management, and it has nodes with sensors that are directly deployed on plants to detect things like air, temperature, humidity, soil moisture, leaf wetness, and lots more. So I'll go over an overview of what I'll be going through. Firstly, the key technical features, which details the basic setup and hardware components of the system like the sensors, nodes, wireless units, and remote server. Then I will talk about the wireless protocol that is used in this setup. After that, the business benefit that this system brings to vineyard owners, which is mainly the availability of information about their vineyard anytime, anywhere. And lastly, future developments regarding this system and its technology. So the setup for this sensor network would consist of sensors deployed on plants, which are connected to nodes, who are then wirelessly synced with a GPRS gateway, and then data from the gateway is sent to a remote server, hosting a web interface for access. And these are how the actual hardware looks like. The nodes are based on 868 MHz Mica modes from the Mica 2 series and uses TinyOS due to their power saving management and good trade-off between maximum radio coverage and transmitted power. The GPRS gateway features a miniaturized GSM GPRS modem with a TCP/IP stack, a powerful 50 MHz clock microcontroller responsible for coordinating the bidirectional data exchange between the modem and the master node to handle communication with the remote server. An additional 128 KB SRAM memory added in order to allow data buffering even if the wide area link is lost. And several audio-digital channels available for connecting additional analog sensors and a battery voltage monitor. It also has a rechargeable battery and solar panel and two-way data flow, so instead of just receiving data, the user could also send data to switch things on and off like irrigation control. And finally, a remote server that provides online portal accessibility. Now to the sensor sets, which consists of a temperature and humidity sensor, which checks for different microclimatic conditions to prevent diseases or frost prediction. Leaf wetness sensor, which is a unique double-phase sensor discriminating top and bottom side wetness. Soil moisture and temperature sensor, which accurately measures soil moisture and temperature, optimizing irrigation and saving water. Dendrometer, which is a micrometric trunk diametric growth sensor measuring plant water stress, which basically means a plant's water retention leading to wider trunks. Data between the gateway and protocol handler are carried out over TCP/IP communication and encapsulated in a custom protocol. There can be up to 255 wireless nodes connected to multiple sensors each, connected to the gateway in a radius of 25 hectares, or 150 hectares with repeaters. The wireless protocol connecting them is based on the IEEE 802.11 distributed coordinated function. One of the main problems with this sensor network was idle listening due to the power consumption, which is improved by synchronous transmission asynchronous reception, which means having the nodes alternate between sleep and listening times and then being weekly synchronized so that they know which neighbors are sleeping and listening. This addition to the wireless protocol greatly enhanced the battery life of the nodes. As for the business benefits, obviously being able to access real-time information about your vineyard from anywhere and at any time in itself is already a huge benefit. For instance, it can provide irrigation management support depending on soil sensor readings, measuring water percentage at root level of plants near the surface. A user can then know the optimum times to turn irrigation on or off remotely. Data from these readings can also help to correlate soil moisture with physiological vine development, ultimately resulting in better crops. All these available data derived directly from plants in the field allows for very accurate predictive models and also helps identify specific problem areas in large fields. As for future developments, currently this system is being developed to the more general field of environmental monitoring due to its flexibility, scalability, adaptability, and self-reconfigurability. And as always, incremental improvements to battery and networks that are ongoing make this technology ever more robust. Thank you.